In this video, we are going to follow a similar procedure as we did before to develop strain versus effective stress plots and relations. So depending on the nature of the data and the application of it, it may be more applicable to use strain and effective stress instead of void ratio and effective stress. So this piece is pretty new to us. We have not covered this specific topic in our previous course, okay? But this procedure we're following is very similar to the one we saw in our previous video. So what we're going to do first is we're going to say recall that axial strain is what? What is axial strain from mechanics and materials? Well, it's epsilon equals a change in height over an original height. Now I'm using capital H here because, I'm trying to use the same nomenclature that we use in geotechnical engineering, but this is just the basic definition of strain. It's of axial strain, change in height over original height of something, okay? So what we do is we compute strain values for each load increment, okay? So what we do is we'll start with epsilon sub 1, and that's going to equal delta H1 over H naught, okay? So epsilon sub 1, of course, is going to be the strain for load increment number 1, all right? So we'll make a note here. This is for load increment sigma prime 1, all right? Now, what about epsilon for epsilon 2? Epsilon 2 is going to be, is it delta H2 over H naught? Not really. It's delta H1 plus delta H2 all over H naught. Because remember, you're talking about strain. You got to include what's already happened in the previous load increment. So epsilon 2 here it's like a cumulative strain. You're accumulating more strain every day that you run this test. All right, so as we keep going, we can say dot, 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 and we can say epsilon sub I equals the summation of delta H sub j as j goes from 1 to I, all divided by H naught. Now, let's be clear on our labeling here, okay? Delta H sub j is the change in height of the soil specimen from the beginning of first loading. That's when you first put the specimen in the consolidation cell and you turn on the load. So this is, from H naught, very first loading, up to load increment I, okay? So then that's not a typo. That is load increment I. So, oops, didn't mean to scroll there. The J here, the subscript J, is only a counter. So it's just helping us count up during this loading. I'm trying to erase a little dot there. There we go. Counter. And I is the load increment of interest. Okay. So that's pretty much it. So let's see how this is related to our void ratio data from the previous video. So we're going to say, so E1, that's void ratio 1, corresponds to epsilon 1. E2 corresponds to epsilon 2, and so on. Okay, and so of course E sub I, which we know from our previous video is E sub I minus 1 minus delta E sub I, corresponds to epsilon sub I, which is the summation j goes from 1 to I of delta H sub j, all divided by H naught. Okay, so this is how we can kind of see how our data from void ratio has a corresponding strain value as we load this. So you can, again, the whole point of this is we can develop strain versus effective stress as well as void ratio versus effective stress. And in some cases, you're going to be more interested in the strain value than you are the void ratio value. So that's going to conclude this video.